Hey guys, so to start this tutorial you need the files from the last tutorial, so part 2. So just download them, go to our site and you're good to go to start this tutorial. So to start us off, we're going to select all our nodes except for the top 3 ones, and then we're going to put those into a subnet. And after you've done that, let's color this one green. And let's call it WalkGen for a bit of an overview. Alright, then one thing we want to add to this is a carve node, because we're going to set the door point now. We're not going to select it manually anymore. This carve node is going to be set to extract, and with this we now have a point we can select on our original primitive. And let's set it to around that place. Then if we go into our subnet and we drag the second input down, you can see that over here we're selecting the door manually, and that's not something we want to do. So let's just delete this thing and let's drag those 3 up and place down a point hook and wire in the second input into the second input. And there we go. Let's go in here, then place down a near point, and we want the position to be the position of our carve point, which is the second input. So let's place a get attribute. This needs to be second input. It needs to be position, and because it's the only point, it's the first point, and that means it's automatically already selecting it. And this will go into the position. Then we're going to wire in the original, so the first input as the input of the near point, and this will give us the closest point, the most nearby point to our carved point. Alright, and that point we're gonna use it to set an attribute. And for now I'm just simply going to call this near point. And it needs to have an integer value of 1. So I place down a constant value, and I will wire this into as the value. Alright, there we go. And now I'm going to place down a group expression. And this group expression I'm going to select a point based on door point, if that's 1. Alright, let's make sure it's set to points. And no, something is wrong here, so let's have a look. And our, oh, I called it near point, I see. Let's just change this to door point. There we go. And now if you look at our group, you can see we have a point selected, and this is now procedural. And that's what we wanted. So now you can have a look again at this. And of course we also need to have the same name for our group, and that's a door point. There we go. And now we have a little nice generator again. Let's mess a little bit with this value, with the grid size. Let's make it a little bit larger. Not too large though. Let's do something like this for now. Alright. Now, first of all, place down a poly expand node. And this poly expand node, we're going to set the width of our walkway. But as you can see right now, it's also going over the edge, and that's not something we want. So we can place down another poly expand node, and we're gonna wire this into our after the sort. There we go. And we only want to keep the inside. And then this offset needs to be the same as the one at the bottom. So if we now look at our original walkway, we can see it is at the exact, it doesn't overlap anymore. So that's really nice. That's exactly what we wanted. I am, however, going to multiply this one by a little bit, and that's because I'm going to use the boolean later on. So I'm going to multiply it by 1.1. There we go. So now let's place down a boolean and also place down a polyextrude. So the polyextrude will take the polyexpand output and we're going to extract it by 0.1 and also output debug. And now it's going downwards, so I'm going to place down a transform node. And this transform node, we're going to transform this up by a little bit, so it's nice in the middle. And now it's ready for a Boolean operation. We're going to wire in our sort. The first one needs to be set to surface and the second one is a solid. So it's nice, and then we're gonna subtract. And now we have our basic mesh for the next operation. Although I'm gonna change a little bit of stuff. I'm gonna play around with this one a little bit more. Let me just look at this. There we go. All right. So maybe instead of this, let's do minus $, let's say y min. And also do the same for the max value. And multiply those two with 0.5. This will get it to the middle. So if it's above, then one of the two will be 0 and vice versa. So now it's nicely in the middle. And let's have a look at this. So this is just for, so imagine you have your standard polygons. Right now it's a little bit junky, but to solve those issues, it's a nice challenge, but it's a little bit too much to solve in this one tutorial. So for now I'm gonna leave it as it is. And what we have right now are some base polygons we can solve for rooms. So if I make this a little bit larger, and I will place down a for each primitive. There we go. We can now loop over each primitive to do stuff. And when you select the Boolean, I also want to create A-B seams groups. So if I place down a group promote right now, and I'll select A-B seams, and we'll set it to edges. You can see those are the edges connected to our walkway. So those are the ones we will be needing. Let's place down a dissolve node. Let's wire this into our for each node. And this dissolve node is going to select our AB seams. And let's make sure everything is loaded. All the groups are in there. All right, there it is. And we are going to be deleting non-selected and create curves when dissolving boundaries. And this is a nice little trick if you want to make sure you only remain with the edges you have from your polygon. So you have an edge group, and you only want to have those edges as a polygon left, then you can use the dissolve for this. Just a nice little trick. So over here we have our edges selected, and with this I'm first going to place down a polypath just to be sure I have one polygon, and then I'm going to place down a facet node to remove some inline points. And let's set it to this, that's fine, all right. Then I will place down a convert line node. And the convert line is going to convert it to separate segments again. Then I can place down a measure node to select the perimeter, because I want to make a selection based on perimeter. Then a sort node. So now we're gonna sort our segments based on their perimeter. So sort our primitives based on attribute, and perimeter is our attribute we will be sorting on, and I will also reverse it. And then I place down a blast, and I will blast 0 and then everything except 0. There we go. So now we have our longest primitive selected. I will place down a sample node for this. So this is the width of our room divisions. So let's set it to something like this, or this is fine. Then I want to place down a convert line again. This is just a little small trick to get the middle points of those segments. So I'm going to place down a prim wrangle. I will be adding a point on the place where the primitive is, so 0 first, and then I will wire in the position of the primitive. So now I have some points extra there in the middle, so if I remove the number you can see them, and after that I will remove the original prim. So remove prim, first input, then prim num, and I also want to remove the points. There we go. And now we have the original middle point left. Then I can place down a Voronoi fracture. Voronoi fracture is also very helpful if you need some semi-clean way to divide up your polygons for stuff like this, for example. And then we have a basic set to divide our rooms. So this is already looking way better. And then after this, we are going to place a for each prim again. And now you can, with some knowledge from the previous tutorials, you can start decorating your room basically. So first of all, we're gonna have the same thing to select the walkway. So which part belongs to the walkway? We'll select that part. All right. Well, we basically need to dissolve mostly of all the other stuff. Wire this in. But do note that something I want to show you, that the moment you use the Voronoi fracture, I'm using it right now because it's an easy clean way to start with something, but it's not the cleanest way because the Voronoi fracture doesn't really like edge groups that much. So it means I'm losing some information regarding where the pathway is. So which part of this primitive is connected to the hallway. And of course there are millions of ways to solve this. Right now I'm not touching them too much. It's a little bit boring for now, but just know you can do that. Alright, so now we have, for example, a place where we can place down a door. For now I'm just going to use a simple scatter, and I'm going to scatter only one point. And with a copy to point, I will place down a box onto this. And it's going to be a small box. There we go. And then you can do all your other stuff. And right now I'm going to use a poly extrude, but I would recommend to divide it up into segments and then solve all those segments separately. So to first use a resample to divide it into the segments you want, give them orientation attributes, and then use those with a height attribute to make your walls. But we did it in part 1, so for now I'm not going to bother. So I'm going to use a poly extrude real quick now to just show you how the walls could look like. There we go. And then we can merge this and give an example of how a very, very basic room could look like. There we go. Let's throw this into the merge. And now we have a very, very basic setup of how to divide up your building into rooms. All right.